This is Sean DeWitt and Pavel Tatashin's stenography demonstration we weren't able to show during our presentation. What you can see on the screen right now is the 4 quadrants. Top left-hand quadrant is what we're going to use as our cover image. This is the image that we're going to be encoding our message into. The bottom left-hand quadrant is going to be our message data, or the image that we're actually going to be encoding into the cover image. Over here on the right, once it becomes encoded, it will be present in this quadrant is the encoded image. This is the cover image that's carrying the message. And after we recover the encoded image from the cover image, it will show up here in the bottom right-hand corner. So here we go. What you can see here is a VMware window. This is our Linux box. We have our program. We're stating that we're going to use our algorithm -A. That's new one. That's our algorithm. New one. That's new one is what we are shorthand for our new RGB sum algorithm. Our input image, which is going to be our cover, is cover 1. That's the reindeer. Our data coming in is message 1, that's Santa Claus. And our output is going to go into the encoded directory at encode1. And that's the image we can't see in the top right hand corner. And down in the last option is a -J. That means store the results as a JPEG image. And what we're trying to do is show that we can resist JPEG compression and still be able to recover our encoded message after the compression. So let's execute that. Take a second. And once it is done, we'll come back to our window and refresh. And what we'll see in the top right hand corner is our image encoded. It's a reindeer with Santa. But we don't know Santa's there yet. So we're going to come back and we're going to recover our image. What we're going to do is going to do our recovery. -R is our recovery option. Our algorithm is still the one we encoded with, the new one, which is the RGB sum algorithm. And our input is the encoded one image. That's the top right hand quadrant. And our output is going to go to decode1.jpg. We don't have to tell what type of image the encoded image is. It's a raw data extraction. This is just the name that the file will be. We can encode other stuff, but right now we're encoding a JPEG, so we're going to name it a .jpg. We'll cover that, and then we will refresh our page. And in the bottom right hand corner, we can see that Santa Claus has appeared. So our second demo 2, we can see we got a couple people hanging out in the woods, drinking beers, playing the guitar. And that's going to be our cover image. Our message is a picture of me holding a picture of me. It's a recursive encoding. So we follow the same steps as we did before. We're going to use our algorithm, store, using our new one algorithm. Our input image is cover2.jpg, which is the top left-hand quadrant. The 2 dudes drinking beers, playing guitars. And our data is going to be message2.jpg, which is me holding a picture of me. And the output we're going to put out into encode2.jpg. And again, we have the -J flag, which says encoded as JPEG image. Execute that. Once it's done, we'll refresh our page, and we can see the top right hand corner is our encoded image. Go back through the recovery, and we're going to recover. The input images are encoded 2.jpg. That's what we just see in the top right hand corner, and the output is going to be the decode2.jpg, which will show up in the bottom right hand corner once we're finished. come here, highlight our page, and we can see that the image is recovered. Thank you for playing along.